I would like to welcome Dr. Gray, and we can move on to your presentation.
Thank you, and thanks again for the invite, for Calvin, for helping us with our technical issues, and for helping with the talk, putting this together. It's a lot of slides, and I'm going to say I'm only going to get through part of them, but I'm going to share the slide deck with you. I've looked through and screened and see a few faces and names, I should say, that I recognize. So some of this is leaning a little more towards early stage career, but I do have some funding opportunities for those mid-level and senior, and I'll give you plenty of contact information. So let's begin. Some of the biggest issues at NIHS is really how to fund my science. So I'm going to give you a really quick snapshot on navigating the process, and I'm definitely going to spend more time on talking about the specific aims, because we can really go on and talk about review issues and other plans and background, but we're just really going to focus kind of technical details in the specific aims that I think will be helpful. I can't get to the next slide. There we go. So overview, grant process, real quick. Give you some review and grant writing tips. That will include the specific aims page. I'm going to talk about some funding opportunities for students and fellows, probably very quickly, just give you 2 names that are really critical for you to know before you start to apply, and then opportunities for others. So I'm glad to see that other more senior, late stage investigators, middle stage investigators are here, because I'm going to give you just a really quick overview of what we have on the streets right now, and give you a very brief update on COVID, because COVID-19 is really moving quickly here at NIH. And so there's opportunities right now, and there's going to be, I think, more opportunities in the next few weeks, and then leave some time for questions. So I'll just ask Christina or Kelvin, please let me know when I have 10 minutes, and then I'll stop and maybe go directly to those slides and then follow up with questions. So the process is, you have an idea. Whether you're early stage investigator, whether you're a pre-doc, you have to have a research idea. So the black box is this process that we call NIH grant process. It's not an easy process. You may be a really good scientist, but you gotta learn the process. So somehow an idea of yours comes in, and let's hope it leads to some money for you and your institution. So let's just fundamentally talk about NIH's mission. So we all have to back up and remember how we're different, as this is the International Society for Environmental Epidemiology, how NIH differs than some of the other funding organizations. And this kind of will help you understand that NIH seeks to look at fundamental knowledge about nature and behavior of a living system, and the application of that knowledge to enhance health, lengthen life, reduce illness and disability. Now you're probably saying, I don't see a lot of prevention in there, but we are one of the major institutes that really has more of a focus on prevention. But how this sets us apart from like our other funder, EPA, is we're not looking just at the role of the environment and environmental exposures, although we do have a niche for that, but we really are anchoring that in the enhancement of a living system and enhancement in health. So that's where we somewhat differ. So as you know or don't know, there's 27 other institutes and centers here at NIH. Most of them have a disease focus. I'm not going to go through all of these. So although you may be interested in the environment, there are institutes that are grounded in NIDDK, as diabetes and kidney disease. And we have an institute that's on drug and alcohol abuse. NIMHD is one of the newer institutes that we have. It used to be a center, and that's the National Institute of Minority Health and Health Disparities. They do a lot of partnering with NIHS, and they have an environmental health disparities program that we partner with them. And then there's your typical NHLBI for lung diseases. We have NICHD for children's diseases, but what we get majority and most is anything related to environmental exposures. So here's the process. I'm not going to go through it, but basically it starts from you as the investigator working with your institution to submit an application. It gets assigned to a study section. If this is unsolicited, it gets assigned to the standing study sections that we have, or it gets assigned to a separate study section that we may convene if it's a funding opportunity from us. It gets evaluated. We take it for another second level review called council at our institutes. Then we, with the institute director, program directors, we make funding recommendations, and then the director signs off if they're able to and not in conflict, and then we manage the funds, and then you get the funds, your institution owns the work, and they actually have the grant as the institution's grant, although it's your idea, and you get to conduct the research. And that's just something that you really have to think about, that although you wrote the science, it's your institution that owns the grant. So if you leave, they have to relinquish it to you. So have some really good conversations ahead of time with your organization about the possibility, if you're going to move, to take an award with you, because they own the award. So here's 3 personnel that you need to get to know. This is, we call program administrator. There are different levels. There's program officers, there's scientific officers, depending on the mechanism. So we just use this broad program administrator. They are the scientists that you reach out to know what the institutes are looking for. Grants management handle all the NIH policies. They're the ones that write your check. Think of them as your accountant. And then your scientific review officer is the one who takes your application and puts together the roster for those who are going to review and make recommendations based on the science to us on the rigor of the science. So this is just like a little field guide for NIH staff. I kind of went through all this already, and you'll have this, and you can see green is who you talk to while you're submitting your application. Once it's received by the scientific review officer, gives you all the help. And then once it's after review, we take over and work with grants management to get your application funded. So one thing at NIH, there's lots of mechanisms. Good news is we're getting rid of a lot of mechanisms because we want to kind of streamline this process. But I think these are like the tenet. This is our bedrock of NIH. So the R01, those are what most institutes require for you to get to be your tenure track positions. R03s are small research grants, $50K per year for 2 years. Use a lot of those for data analysis. R21 is exploratory developmental grants. That's when you don't have the preliminary data, but you have a good idea and you have to get baseline measures on feasibility, exposure assessment, and find out what the range of exposures are in your population. The Ps are for large programs like our children's centers, Superfund, they're multi-project. Those all come in solicited. We have training grants at your institutions that your mentors put together. We have Fs, and those are for the early stage investigators, and we have K for the early to mid path career development. So many mechanisms, and one key thing is not every institute signs on for every mechanism. And that's a tricky thing. So we can work with you on that. There's plenty of guide notices to help you figure that out. So considerations for responding to a funding opportunity. Those are like RFAs. We're getting away from program announcements, but is what your idea, what they're looking for? Always send your aims to the program official listed on the funding opportunity. Follow every single one of the directions. And it's best to submit a letter of intent, even if it's not requested. That way it gets the review office ready for pulling in people that may have the special expertise needed to review your application. So these are the standard application due dates and review and award cycles for unsolicited grants. These are grants not in response to a RFA, and those cycles are similar, whether it's an R01, an R21, or K. You can see as you get a little bit more to an earlier stage and pre-doc, they give you a little bit more time, where you start here February. The fellowships come in at the latest in April, and cycle 2, it's June, and then the fellowships are in August. But they're all circulating around and anchored in the scientific review period, the advisory councils, and the earliest projected project start date. So applications are assigned when unsolicited to the right institute or center based on these referral guidelines that are already applied. The director's work, make sure we have some boundary issues, and sometimes there are dual assignments. Dual assignments are very important. You can even request that and seek out dual assignments, because if one institute can't fund it, if the other institute's on it, they may be able. We have very little of that, but sometimes an institute gets an extra pot of money, like Aging has right now for Alzheimer's disease, and they've been funding a lot. You know, each round they've been funding a few of our NIHs grants. They're outside our pay line that relate to cognition. So it doesn't have to be Alzheimer's, but for them, cognition and memory. CSR has the study section for the unsolicited, and then we at NIHs and the other institutes will convene a special emphasis panels for certain specific types of mechanisms, especially when we write an FOA. So review meetings, just to let you know what the makeup is, because this is really important for you to know. It's a standing study section. We have epidemiology has about 5 standing study sections. NIHS has one for basic science called systematic injury of environmental exposures, but that's really more for the fundamental science. A few epi go in there when they're actually working on cell-based or working in mitochondria. And so there are some temporary reviewers they bring on each of the study sections when there's a specialty or a specific question that you may be raising in your application that can't be reviewed by a standing study section. Our special emphasis panels, they tend to be smaller if it's a small award, or larger if it's these big program projects. And we get a little bit more specialty in these SEPs. The number of applications reviewed depends on the number received. So they do about, on average, a 50% streamline. So you shouldn't feel bad if your application doesn't get reviewed, because some really meritorious applications are coming back in for re-review, because pay lines are a little, they're very competitive right now at NIH. So just be persistent. So here's the formats. As you know, we're all stay at home. And so most of them, all of them now are not in person. We're using Zoom just like this. And it's working out as a really fabulous resource. We've done a lot of that here at NIHS, but it's a little bit more technically challenging for the standing study sections, but it seems to be working. Just to let you know, on YouTube, there is an NIH peer review mock study section, just to give you an idea of the discussion that goes about, the body language, the scoring, and then the final overall. So here are the criteria for the review. It's always significance, investigator, innovation, approach, and environment. Each assigned reviewer provides a score of 1 through 9. You also get an overall impact score from 10 to 90. I really, since they're streamlining about 50%, the highest is about 50 of those that are peer reviewed. And those that aren't peer reviewed still get a summary statement, just will be considered not discussed. So this is why I'm telling you about the review. You need to know your reviewers. Reviewers are accomplished, they're dedicated, they try to be fair, they're overcommitted, they get tired, and especially in epidemiology, they're overly critical, they're skeptical, they need to be convinced. And since these are mixed study sections, sometimes you're sitting in a study section that's more about your clinical outcome, and they're a little misgiving or not really understanding the role of the environment and how important that is. Maybe diet, they'll understand, behavior, but when it comes to environment, you really have to tell your story. So unless you plan to fund your own research, we suggest you find out who your reviewers are and you write for them and not for yourself. So make it easy for them. Lay things out really logically. Be clear and concise. Don't use any jargon. Try to have other members in your institution read it so that you're a good storyteller and that background and significance. Organize your page and proofread and do it again. Know what they're looking for, the reviewers, and give it to them. So if you have the ability to talk to program has an idea, they listen to the reviews pretty frequently, that they know what some of the big issues are at study section right now, whether it's mediation analysis, whether it's a specific chemical that they're not really grasping and where the hiccups may be. So your key to success at grant writing is really to engage enthusiasm in what you're writing so that the reviewer becomes an advocate for your proposal. Because as things become undiscussed, you just need one reviewer saying, I like this, I think we should discuss this. And so that's one of the critical elements that you don't know about review. So where do you begin? This, we always say, is best to start by writing the smaller parts. So being asked to talk about specific aims, these are the one-page specific aims, which really are the capsule of your research plan. Outline your specific aims, anchor them to one or more hypotheses. So remember, since your reviewers read your specific aims, they almost go straight to their specific aims. You want to excite them about your project. And I know we have a few study section members that are online, and maybe they care later to talk about this as an element. So drafting your aims. So it's important for your research is within your niche. So they're going to look at who you are, your background. They're going to look at your biosketch. And remember, in your CV, you're going to have this statement, your personal statement. So if you're doing something that they can't figure out, where did she or he is moving this field and they've never done this before, that could be a red flag. It maybe not if it's an R21, but you just have to put the package together. Your research, especially if it's an R01, must be supported by your preliminary data, or there must be some published data out there, literature for you to reference. Always think high level. Ask yourself, what is your objective? And can you reasonably achieve it within the time frame of a grant? Epidemiology is historically known for being a 5-year grant, but asking for no cost extensions. We understand that. We approve it somewhat for the first year. You get that on your own, but you really just make sure you can do what you can do within that 5-year. You want to start broad with an emphasis on significance, and then focus on generating your experiments in your head with clear endpoints so the reviewers really can readily assess it. So one of my little tidbits, it's better to think small and propose less than to be overly ambitious. So what's a good aim? What's a bad aim? So here's a couple tips. Common type of aim is, does A cause B? But what happens if A doesn't cause B? Then your rest of your aims don't work. So that's a risky kind of broad statement. So design an aim where the result does not depend only on one outcome, but it maybe the questions become, does A cause B or non-B, or make non-B outcomes that make sense based on your central hypothesis and your preliminary data. Another common type of specific aim is it's way too descriptive. You may be able to do this in an R03 and say, we will measure levels of this chemical in 1,000 samples and Y, the population, to characterize the pattern of expression of X. That itself would not be seen as very innovative and potentially too descriptive that the enthusiasm wouldn't be there. So your specific aims should build on your previous or your current experience. And if you're going outside the box, bring on a collaborator as a co-investigator or multi-PI plan to anchor. Maybe you're more of a methods person, you're the exposure person, but somewhere you have to have the experience or the collaboration to address these specific. Otherwise. And as if what you're proposing is high risk, then it may be perceived as innovative. That's a kind of a catch-22 because there are mechanisms which they call the R21 for high risk innovative studies, but I can tell you that it's harder to get an R21 almost as it is to get an R01. So let's think creatively on which mechanism fits based on the science that you have and how long it's going to take you to get it done. I know there's been criticism on the R21s that it's too few years, and by the time you're wrapping it up, you got to get ready for that R01. So talk to your program director to see what the best fit is based on the science that's going up for peer review. So the research you propose should be new and unique, but most importantly, just make sure it's pushing forward the knowledge, pushing forward the science. Not, replicating something is good, but there has to be something new about it that's bringing new information to the institutes and to the scientific community. So here are some of the other common challenges with applications overall. They're overly ambitious. We already talked about that. Kind of simplify. Epidemiology has this tend to be $499,000 per year direct cost. That's the cap that you can't go over. You have to get special permission. Pull it back. There's nothing wrong with a modular grant that's in epidemiology, especially if you're doing using that extant rich data sources that we have out there that are being released all the time, we hope, and that you have that preliminary data that's required. If you don't have the preliminary data, you better have a lot of other background science to back it up. The limited innovation is an issue in epidemiology, but if you're going to a study section that is a basic epidemiology study section or it's a community health, the innovation just may be the question that you're asking, is it important to that community? Incremental science, that if you're in a mixed study section because you're going to an RFA, You just really have to sell what the public health relevance is here. And I always feel like that, which draws in the epidemiology, we get the extra little bit of excitement about our science, because we normally are nested in a health outcome that most of the reviewers, even if they're a basic scientist, can relate. Make sure one of the common challenges is the research plan is not even feasible. It's overly ambitious. You got too many questions. There's too many moving parts, from an international collaboration to too many people running the samples. Is it feasible? They're always questioning the reasoning and approach. There's not well experience with the methods that they're proposing. So if you just throw out the term, I'm going to do a mixtures proposal, and I'm going to do, you better know mixtures, and you better have somebody on there that knows how to do mixtures analysis. You can't just say the word. They want to see the evidence that you can do it. If you don't have publications in it, then you better have somebody on there that's top in the field, or is trained in that field. And the biggest issue is that your science doesn't generate excitement. So the reviewers briefly go over, the primary reviewer, your aims, and nobody's really excited. And I think it's that introduction and those specific aims that really provide that excitement. And then they do look at your biosketch. They look at the productivity of you. So if there's not a lot of productivity, you either have to fix that, or you have to somehow get a letter of support explaining that lack of productivity. Sometimes there's gaps in people's careers. That's understandable. Just it has to be somewhere in that biosketch or in a support letter where there is a mentor relaying some information to the reviewers about the issues, that there was a gap in your career. There's ways around it. You just have to recognize it and own it. And then the lack of attention to detail. So funding considerations. So you get this application, you put it in, whether it's an F fellowship application, a K or a T or an R, everybody gets a summary statement, whether you got discussed or not. If you get discussed, everybody else pitched in scores and had comments, and there was discussion. If it's not discussed, you're really just getting those assigned reviewers' feedback. That's it. They didn't talk about it, but it didn't get discussed. Remember, I told you, don't let that be a problem. 50% doesn't get discussed, but come back. The programmatic priorities of the Institute. This is something I'm going to share with you called NIHs. This is something that we resurrected from the 2000s, used to be called special emphasis areas. They're now called notice of special intent, where we will start telling you what our specific program priority areas are, where we may give you a little bit of edge if you're outside that pay line. We also do that for early stage investigators. Everything goes for second review at our advisory council, and for those advisory members that aren't in conflict, they get to read the summary statements. They kind of get an idea of what our baseline pay line is, and they make recommendations to see our specials and have some discussion about that. And then at the end of the day, we meet as a team with our director, with our budget office, and we talk budget. So when an epidemiology is very large and you're on the bubble, we look at the basic science that there's 2 R01s that were smaller could actually, will be lost if we pay one epidemiology. It's something that we always deal with. So that's why we're saying, try to design things that are nimble, so it's not hard for us to pull you in if you're just right not at that that perfect score, and the priority score is 200 percentiles of the 10th percentile. And then finally, the person that makes the funding decisions at the end of the day is our institute director, unless they're in conflict. So just want to tell you briefly about the difference between a new and early stage investigator. A new investigator is someone that's never been a PI on a significant research project. That's an R01. You can have R21, you can have an R03, you can be on anything else. But if you weren't the PI of an R01, then you're considered a new investigator. And if you've been out of your residency or postdoc 2 years. Now, the early stage investigator is the one that NIH has really made a commitment of fostering opportunities for. These are the new investigators who finished their research degrees, but are within 10 years. So we make program priority decisions based on, are they an early stage investigator? You lose that status if you come in on a multi-PI plan with somebody who's more senior. So we always recommend, if you're an ESI, come in by yourself. But if it's a really good idea and you're very collaborative and it looks like a great grant, then go for the multi-PI with your senior partner. For epidemiology, the multi-PI plan works a lot because you may not own that data, but a good support letter, having the program director of that research consortium as part of your grant application sometimes does suffice. So recommendation, call the program administrator before submitting, preferably before you complete the writing of your application. Giving it to us 2 to 3 weeks before, I don't want to break your heart. You know, we want to give you constructive criticism. If you're that late, you may not even want to talk to us because we don't want to really change it too much, but earlier in the process, the better. So there is a separation between program and reviews, and that's a decision that's how the Institute works. That's why it's the Center for Scientific Review. The program staff identifies, writes RFAs, promote research priorities. We recommend projects for funding, and we manage the science itself. And we work with the applications up front. Review, manage the study sections, and they evaluate the scientific and technical merit. This is rigor and reproducibility. They're giving us the priority scores. They provide a fair and thorough and competent review for each application. You cannot recommend reviewers for your application to the review staff. We make recommendations to the review and CSR and the SROs on who should be on that based on what we know is coming in. So that's why it's important to always talk with your program first. So we have an idea of what's coming in. And then the review staff works with the applications also before review because they like seeing what's coming in, but do not recommend anybody to them, put it in writing because that person would be in conflict. So I'm going to pause here and then just going to walk you quickly through the opportunities for students and fellows and give you a really important contact information for who will help you through this process.
Kim, just heads up. We're at
oh, great. Okay. I'm just going to go through these very quickly. So this is just the training, research, career support paradigm. This is basically as a high school student, college student, graduate student, faculty position. These are all the different mechanisms and support we have at NIH to offer. So fellowships to support an individual in full-time research training. These include stipend, tuition, fees. Citizenship is required. They are for individuals and they don't support the research. So you have to find someone to partner with who's going to support you by giving you the research. So here are the current NRSA fellowship opportunities. F30 is pre-doc. F31 is an individual pre-doc. F31 is a pre-doc to promote diversity. And an F32 is a postdoc fellowship. One of our most, this is where we get the most early stage investigators coming in, and this is a very successful program. They call it the Kangaroo because you're jumping from the K99 mentor phase to the R00 independent. So this is a pathway to independence. You get 5 years of support total, 1 to 2 years in the mentored phase, and 3 years in the independent phase where you're going to take this grant to where you want to go to develop your science. So you have to be a postdoc or in a mentored position, no more than 4 years postdoc experience. And here's the difference. We allow US citizens and non-US citizens are eligible for K99s. Intramural can apply, extramural and for-profit. You cannot be a PI on an NIH research grant or career development award or have any non-NIH research support. So you have to be careful about some of the foundations of over 100,000 per year. So here's the eligibility. There's some extensions I want to let you know for women and husband and fathers who have a child in between. They will extend some of the mentored period policies here. Here's some of the nuances about it. They require 12 months. You have to do the mentored phase at least 12 months. Sometimes it takes a couple rounds to get in and reviewed. We do those reviews here, but normally within 2, you kind of have a feeling of whether you're going in the right direction. 2 rounds, and consequently, an individual cannot provide a compelling rationale for at least 1 year, we won't fund it. So here is it looks like a pretty simple application, 12 pages, 6 for a plan for you have to get something from the mentor, something from your collaborators, and a bio sketch And this just starts to really add up. So it's over 100 pages. Here's the regular submission dates. These are offered each round, so you can amend and resubmit each cycle. Here's some additional case support that we have, KO1s. For early faculty, I'm not going to walk you through these because I want to get to some of the more senior level opportunities, KO1. The tier grant is independent. You have to have a sponsor for that as well. And then here's our outstanding new investigator. This is for anyone that's in that ESI, can apply to our RFA with a set-aside fund to fund 4 to 5 applications where we identify the most talented early stage investigator at an institute. They're nominated from their institute. We take 1 per institute, and it really launches their career research program. This is just for ESIs. And here's the key. Mike Humble runs our fellowship program. The career development program, the Ks, and the ONES program is run by Carol Scheffler. For the more senior and mid-level career scientists on the phone, we have, this is our request for applications as of today. So we have the River, which is for anyone who has an R01 that is about to end. You can continue your science by getting an 8-year award for about $700,000 a year. It's about people, not projects. We have the core centers, which are pretty much, that's for very senior level for an institution award for environmental science. The other one that's interesting and applies to us in environmental science and epidemiology is research to action, as well as this virtual consortium, which is the Victor program, where you as an epidemiologist would partner with someone outside of your field to address a new question. It's a short 3-year program. I wanted to talk to you about a new opportunity we have. It's an R01, R21 for environmental risk related to psychiatric disorders. We really haven't had something this targeted except in autism. So this is everything but autism. And I have the RFA for that. So we're looking at what are those exposures associated with early life psychiatric symptoms? Are there early life biomarkers that are related to the trajectory or the onset of symptoms? What's the underlying neurobiology? Are there critical windows of exposure? And do environmental exposures interact with other stressors to exacerbate psychiatric disorders? Our research to action program has an RFA on the street for 2 more years. This initiative follows under our Public Health Network, PEPH. It brings together community members with environmental scientists, meaningful community engagement. The requirement is data collection, translation of the research to public health, and project evaluation. The Cheer to Hear program is Children's Health Exposure Analysis Resource, is now Human Health and Environment Exposure Resource. Any NIH grant funded by NIHs, NCI, or NHLBI can come in and use this resource to expand their environmental characterization of their cohort. They don't pay for you to ship your samples, but they will provide the analysis. They will also do the data analysis if needed. There is the only caveat, and is not a caveat by any means, they develop the data meta standards for you to use, and the data that they give you becomes publicly available in a secured site. Here are the other members of the population health branch. Claudia Thompson is our branch chief, and she runs the core centers. New to our branch is Lindsay Martin. She is a health disparities, she'll be running our health disparities portfolio. She comes to our institute with training and dissemination and implementation. Bonnie Jover, I'm sure a lot of you know who she is. She runs our PRIME program. That's our mixture stats program. She does the kidney portfolio as well as our respiratory. Liam O'Fallon runs Research to Action now and Partnerships for Environmental Public Health. AB is Cancer Epidemiology and Women's Health, Reproductive. And then Thad is kind of like our basic scientist has come to our branch to help us with the translation. He did a lot of the movement of the BPA program. And now he's working a lot in placental biology and endocrine disruptors, and also partnered with AB on 2 recent RFAs to look at women's reproductive health. Here is a great site for you to learn about grants and the process. This one is great for applicants. I will share this with you, from the process to the writing to the deadlines. And this is kind of cute, the frequently asked questions. This one is really important, and I will make sure that you get this one. Everything is changing very quickly with this natural disaster known as COVID-19. So we're giving you guidance on your applications for those of you who are in the field and have shut down. We're giving you guidance on applicants about late applications because you can't get it processed. This is a one-stop shop for all the news that we have and everything that we're pulling together in response to the coronavirus. Because we understand there's new research questions to be asked. You want to characterize COVID maybe in your population, but these are just the steps of what happens with the funding that I have in the application process I'm going through now. Another one, this is really good, is we refer to this for NIH to get all of our coronavirus information, so you can get the updates from NIH. This has all been vetted through Fauci. It's a pretty exciting time. I'm feeling more optimistic and hopeful about our battle with COVID-19 when I see everything that's going on in the scientific world. And it's pretty it really takes this time where you feel really isolated. And why am I doing all this? And is it all for the better good? It is for the better good. And we'll get through this. So I want to thank you. Thank you for your time. I wanted to thank Christina and I wanted to thank Kelvin for helping me put this together, and for the Capacity and Education Subcommittee for allowing me to be your guinea pig for your webinar series. And I have a lot more to say, as some of you on the line know, but I'm going to pause here and take any questions.